All right, grade 8, here we are. Next lesson that we're going to work on. We're talking lesson 90. We're going to be talking about sets. So this lesson here is probably a little bit more difficult, so bear with me, follow along. It's important that you catch all of these concepts. So a set is basically a combination of elements. Now elements can also refer to things that are equal. So when we're making sets, we're looking at doing creating a set of numbers or things that are similar. Okay, so here, for example, 1, if you're following along on page 599, it says create, use set notation. Now that's a specific language that they're using. Use set notation. So when you see set notation, that's going to help you understand that they're looking for you to show it in a certain way. So here it says use set notation to denote or show the set of even integers. Okay, so when we put our parentheses in here and our dot 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 followed by a comma, and we put -4, -2, 0, 2, 4, dot 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 dot, and then your parentheses at the back. Essentially what that's showing is the dots show that it continues going backwards that way and continues going forwards that way. If you don't have a dots in the beginning here, that shows that there's a definite start. If you don't have dots at the end, that means there's a definite end. Okay, so that's really what it's showing you when it says denote the set of even integers. Okay, so when we move on, example 2 talks about something slightly different. It says use set notation to indicate, that's different, to indicate whether each number is an element of rational numbers. Now, element is shown using a rounded E. So when you're using a rounded E, that's what an element is. So it says, is it a rational number? A rational number means that it has a definite ending to that number. So 2, is it an element of rational numbers? Yes, it is. So you would write it this way. 2 is an element of rational numbers. So that would be A there. B, it says, well, is half an element of rational numbers? Well, yes, it is, because it's 0.5 is exactly the same. It is an element of rational numbers. When you do the square root of 2, here's where it's slightly different. Square root of 2, and you can try that on your calculator if you'd like, but it's a number that goes on and on. And so that would not be an element of rational numbers. And that's where you put that line through your rational numbers to show it. Okay, so when they ask you if something's an element of it, they're asking you to write it in this way. Okay? Example 3 asks for you to do it in a slightly different way. They're asking you, it says, graph the elements of each set on a number line. So for A, we draw, sorry, I gotta move my iPad here. It is hard to write this way and I'm writing very messy. So for A, we would draw our number line, right? And it's asking us for integers. Now we know that integers are definite points on the line, so we mark them down as definite points on the line. So here you go. This is showing how that would work on a number line. Okay, and the next thing it says, show the square root of 1, square root of 2, square root of 3, and square root of 4. Again, you could do that on a number line as well. Remember, number lines have numbers, not square roots. So we have -2, we have negative 1, we have 0, we have 1, we have 2. So the square root of 1 would fall right there because the square root of 1 is 1. The square root of 4 would fall here because that is 2. But then you'll see that the square root of 2 and the square root of 3 fall in between there. Okay, so that should help explain that as well. The next, we're going to learn about different terms. Okay, so this will take a little bit of time for you to internalize this, and that's what it's talking about in example 4. Remember, you can pause the video if you want to read it in the book. It's also on page 600 in the book. But it talks about specific terms here, and I'll zoom in here so you can see it. So N would be natural counting numbers. Z, fancy like that, would be integers. Q would be rational numbers, and R would be real numbers. Okay? Basically, a rational number should be able to be expressed as a fraction. All right, so let's move on a little bit with that. So example 4 says use the subset symbol. Now a subset, that's a new term, subset. Now these are going to be a little bit more difficult to follow because a subset is basically a fancy U that's tipped on the side. Now we're going to be using subsets in a specific way, and it says natural, which are counting numbers. Are they a subset of integers? Yes, they are, right? They will fall into integers. Now counting numbers are not all counting numbers are, not all integers are counting numbers, but that can be written that natural numbers are a subset. They're part of integers. So natural numbers, and I don't know if I can do it so fancy on here, are a subset of integers. I'll try to make a fancy Z here. And that would show you the solution to that. Okay, moving on to example 5, you got two different U's. An U that follows this way and a U that follows this way. So when you're reading through that, you have two different terms. You have an intersection. Now intersection is easier because intersection is the upside down U. And an intersection, of course, you know, is a place where things meet. You also have a union. This one here is asking, sets A and B are shown below. Find the intersection of A and B. So what would you think would the intersection of A and B be? Well, you see that A and B intersect with two different numbers. You'll see that A and B share or intersect 2 and 4. Those are the only ones that they do. So that would mean that A intersects B at 2 and 4. All right, now what's the union of them? What is it all together? That's when you put them all together. So A, the union B equals, well, what do we get? We get 1, 2, 3, 4, 6, and 8. That's the union. When you put them all together, that's what you have. So we've learned a bunch of different terms. We've learned subset, which is a sideways U, intersection, which is an upside down U, and union, which is just a regular U. So U for union. All right, now it talks about Venn diagrams, and we've learned about Venn diagrams before, I am sure. Venn diagrams can have many different factions. They can have two different pieces that have their own, that are separate, but share a piece. Or the other way that you can think about it is that something can be a subset or a part of that whole. And that's really what is working here with example 6. Okay, so it says use a Venn diagram to illustrate for A what is, to illustrate A equals 1, 2, 3, and B is, and it's got an N there, and we learned already that the N stands for counting numbers. Okay, so let's draw it. You'll see that counting numbers are going to fall within natural numbers. Okay? And so we have A is, of course, we have 1, 2, 3. So natural numbers, 1, 2, 3, 4, dot, dot, dot. They continue on. And then we have B, or A, sorry, which is the numbers 1, 2, and 3. They will fall within that same part of natural numbers. Make sense? All right, then we move on to B, and B says the intersection of we're going to find the intersection of A and B here. So let's draw that one. We have A, which is 2, 4, 6, and we have B, which is 1, 3, 5. So, well, we didn't finish A off here. A intersects N with, oh, that's a fancy N, 1, 2, and 3. B is slightly different. As we see, none of those numbers intersect, right? So essentially with a Venn diagram, because they don't share anything, A will have 2, 4, 6, and B will have 1, 3, 5. Is there an intersection? No, there's no intersection there, right? So we have A, and then we have our intersect with a line through it, does not intersect B. Equals, what do we have? We have 0 numbers in there. Okay, so an empty set, that's what that means, empty set. When you got nothing, there's nothing that matches together. Okay, hopefully, you might have to play this through again to understand it, read the book as well, but this takes a little bit of time to internalize all of these concepts. So what I'd like to do now is go to the practice set and work our way through that practice set. So A is going to have -1. That's what it says, -1, and then it says indicate if the number is an element of the set of integers. So remember, we're going to have an element in there. So is -1 an integer? Yes, it is. It is an element of integers. That would be the answer for A. B is asking us, is 2 an element of integers? Yes, 2 is an element of integers. C is asking us, how about the square root of 3? Well, we know that the square root of 3 does not give you an integer. It gives you a number between 1 and 2. So that's not going to be an integer. Integers are negative or positive numbers. So the square root of 3 is not an element of integers. All right, moving on to D. Use the subset symbol to show the relationship between A and B. And A would be all triangles, and B would be all polygons. So that would be D. Let me write that down. So A is a subset of B. Triangles are part of all polygons, subset. So that's what you're looking there for your subset symbol. All right, moving on to E. You can try it on your own at any time. Hit pause and see if you get it right. E, A equals R, and R stands for real numbers, and Q stands for rational numbers. Okay, so rational numbers, so which one is the subset of which, right? So real numbers and rational numbers, if we think about it. So rational numbers would be a subset of real numbers. So B would be a subset of A. Hopefully that makes sense. This stuff is pretty tough. Okay, vowels and letters of the alphabet. So that's F. And we're looking at how that would have a subset, right? So if we look at vowels and letters of the alphabet, well, vowels is A, and the whole alphabet is B. A is a part of the whole alphabet, so it will be a subset. You can't do it the other way around. Remember, you have to show which one's going to be the subset. Okay, that would take care of that part of it. Let's move on to G. G says use a Venn diagram to illustrate the relationship between the sets. Find the intersection of A and B. Remember, when we have this symbol, we have intersection. So where do they intersect? Where do they meet? All right, so for G, let's mark that down. G says we have A is 3, 6, 9, and 12, and B is the B is 5, 12, 15, and 20. So where do they intersect? Well, they intersect at 12. So A and intersects B equals 12. Okay, and the next one, all parallelograms and all trapezoids. Well, those are two different things that we're talking about, and so if they don't have a subset, if they don't intersect, we have to mark that down. So A does not and B do not intersect equals 0. Okay, so if you wanted to put that into drawings for Venn diagrams, I'm going to do G and H again, just show you how you would put the Venn diagrams. So G has certain ones that match. So when we look at subset A, we have 3, 6, and 9 that are on the outside. And you see that 12 is the one that they share in common. And then we have 5, 15, and 20. H, of course, we have parallelograms and we have trapezoids, but they are totally different. They don't intersect at all. All right, moving on to I. I says use a Venn diagram to illustrate the relationship between the sets, then indicate the union of the sets. Okay, so 10, 20, 30, union 20, 30, 40. That means, what do we have? We have two that meet together, right? And we have 10, 20, and 30, and then 40, because they share some numbers together. So A union B would be 10, 20, 30, 40. Union means essentially you're putting them all together. All right, and then the last one that we have for this set is J. And J says if we have 2, 4, 6, 8, 2, 4, 6, 8, and we have a union with 4, 8, and 12, what do we get? Well, let's put that together. Okay, so this is slightly different because the one completely falls within the other. We have 4 and 8. Did I miss a number here? Yeah, it has a dot, 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 dot. It keeps going on. So we know that 12 goes in there as well. So we know that 2, 6, 8, and 10 would also be there as well. Dot, dot, dot. It keeps going out. But those are the ones that are together. Remember, those dots mean that it would continue on. Right? So those continue on. So that's how you would draw that. What would the union of that look like? Well, the union of those numbers would be 2, 4, 6, 8, 10, 12, dot, 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 dot. It continues on. So hopefully this made sense. Go through your work again today. I would like you to do evens.